Today we're going to talk about elements and compounds and the formulas for those different elements and compounds. What are they made up of? Elements, for instance, are made up of only one kind of atom. If you have a bar of iron, then you have all iron atoms. They're all one kind of atom. And this is an example right here of the atoms that exist in a pure element. They are all identical. Copper, if you have something that's made up of copper or copper wire, for instance, then every atom in there is copper, made up of atoms. Compounds, on the other hand, remember that compounds are made up of two or more elements that are chemically combined. So you have formulas for compounds that consist, again, of at least two elements, perhaps more, as it is here for this compound for sugar, sucrose. When we have a compound, the subscripts in the compound refer to the number of atoms that are present in that compound. So one of the worksheets that you're going to be doing involves counting up the atoms of each element that are in the compound, and this is what I want it to look like. If you have this first one, Ca3P4, those subscripts indicate that there are 3 calciums and 4 phosphorus atoms. So that's just a very simple formula. The subscript always follows the element it refers to. The next one, CH3COOH, please make sure you notice if there happen to be atoms of the same element that are in different places in the formula. And this happens a lot in organic chemistry when the formula is, they're trying to get the formula to represent kind of what the compound looks like and to make it recognizable to an organic chemist of what type of compound it is. This, for instance, is acetic acid. The COOH on the end tells us that it is that organic acid. So what do we do with those? We just simply combine it. We know that there are 2 carbons here. They're in different places, but there are 2 of them. There are 3 hydrogens here, but watch out because there's a hydrogen here as well. So there's a total of 4 hydrogens. Also notice that there are 2 oxygens, so don't forget those. And that's the breakdown for our compound CH3COOH. Now, if there are parentheses in the compound, it works kind of like it does in math. The subscript that's outside the parentheses multiplies by everything inside the parentheses. Sometimes I tell my students that if there's only one element, you might want to go ahead and mark that so you notice that there's 1 oxygen and 1 hydrogen here, and you treat those separately. So this particular compound has 1 barium. Notice since O and H are in parentheses and there's a 2 after it, there's 2 times 1, or 2 oxygens, and 2 times 1, or 2 hydrogens. If you can do the next one, you can do any of them, and you might challenge yourself to pause this really quickly and see if you can do the next compound yourself. Hopefully you tried it and you came up with the fact that since iron is not in parentheses, it simply has a 2 after it. That indicates that there are 2 iron atoms. But Cr2O7 is in parentheses and there's a 3 after it. So that indicates that there are 3 times 2, or 6 chromiums, and 3 times 7, 21 oxygens. Now be careful. I have students all the time tell me there are 5 chromiums and 10 oxygens. You do not add with that number outside the parentheses, you multiply, so watch for that. Now there are 2 different kinds of compounds, and those 2 compounds are identified based on what they're made up of. An ionic compound is the first type. An ionic compound always has a metal. Remember that metals are left of the staircase on the periodic table. They also have a nonmetal, and those are to the right of the staircase, remember, on the periodic table. Ionic compounds then also have a different structure. They have what's called a lattice structure. They do not have molecules. That is a very important. When you're in lower level classes, they also often tell you that compounds are made up of molecules. Well, it's true some compounds are made up of molecules, but ionic compounds, the ones that have metals and nonmetals in them, are actually in a lattice structure like this. And that lattice structure, I used to think of it as Tinker Toys or Connects, and they're just alternating atoms existing in this lattice structure. So there are no individual molecules. No molecules. We say that these substances are made up of, these ionic compounds are made up of formula units. We call them formula units, and we come up with a formula unit by making the smallest ratio of atoms. For instance, in the compound that I've circled here, it's a good representation of something like salt, for instance, NaCl, where for every one blue, you've got one yellow atom, a 1-to-1 ratio, so the formula for that compound would be NaCl. If you had two of one atom for every one of another, you might have a compound like BaCl2 or something like that. So it's always the lowest whole number ratio of the atoms in that compound. A more familiar term for us is that of the molecules that make up molecular compounds. Molecular compounds, also we'll see in a later chapter, sometimes called covalent compounds, are made up of all nonmetals. All nonmetals. And molecular compounds do have discrete molecules. Discrete meaning individual, apart from each other molecules. So I could go up here and very quickly circle and count the number of molecules of water. This is a good example of the water molecule, for instance, up here. And you can see the difference in those two structures between the lattice structure of an ionic compound and the molecular structure of a molecular compound. So when you see the formula of formula of a substance, I expect you first of all to know whether it's an element, an ionic compound, or molecular compound, and then to be able to tell me what types of particles or units they're made up of. So we're going to look first of all at what that particular substance contains. The first one contains carbon and oxygen. If you look on the periodic table, you'll see that both of these are nonmetals. Since they're both nonmetals and there are two different elements in it, it is a compound, specifically a molecular compound. So a molecular compound because it has all nonmetals in it. And since it is a molecular compound, this one's easy. It's made up of molecules. The next one has a single element symbol, Ag. That single element symbol indicates to us that this is an element. And since it is an element, it is made up of atoms. Finally, the last one has chromium, sulfur, and oxygen. Both sulfur and oxygen are nonmetals, but chromium is a metal. So this compound is made up of both metals and nonmetals. It's a compound because there's more than one type of element in it, type of atom. So since it does have a metal in it, it is an ionic compound. And remember, ionic compounds are made up of, they have that lattice structure, and we refer to the particles that it contains, if you will, as formula units.